All right, so let's get started. So my name is James. I work at Couchbase, and we develop open source frameworks. And among those, there is one in particular that we developed starting 3 or 4 years ago to build offline first applications, and it's kind of a buzzword. So through this talk today, I want to sort of do a thought experiment and see the different ways in which you can build offline first. We'll have a few demos as well. Just a show of hands, who's heard of Couchbase before? All right, cool. So I'll give a quick overview of the different components that enable us to do offline synchronization, and then we'll go more into Android as a result. So when we came about building Couchbase Lite a few years ago, we were thinking, what are the big principles that apply to mobile development? And obviously one of them is design. If you get handed over from the design team 30 to 40 screens, it takes an incredible amount of time to implement that in the UI. And even more when you have different resolutions on the same screen sizes, different aspect ratios. So if you want to make your users happy, you have to have a good UI. But with that, you need to put data on the UI. And we were thinking, if you're going to make a query to the database and then you're going to make an HTTP request, would it be possible to sort of abstract this away, if you will, so that you would have less boilerplate code and one code path in your app to fetch maybe the document from the database, and eventually if it's not there, it will take care of getting that document from the server. But also without compromises, so you want to keep a responsive application even when the user is offline. And so it's all about data, at the end of the day, about data syncing and sharing, the way you develop your RESTful API, the way you develop your authentication. Will that work offline? How long will that work offline for? And we started taking the basic two components that we're all familiar with, so the mobile and the server. And it was pretty clear that we had to develop an embedded database that would ship in the app. And so we call that Couchbase Lite. And in the SDK, all you do is just reads and writes to that database, like you would with any embedded database. A few things to note here is that it's like a NoSQL database, so it's a flexible schema. The data is stored as JSON. But once we had this done, we were thinking, why not try and replicate what's in the database to a server? And I use the word replicate because it kind of stems from CouchDB. Couchbase was a merge of two companies, one of which was a community-led project called CouchDB. And this is basically what stemmed from CouchDB and that we use and we have extended to be able to have like multi-master replication. A few keywords to know here is when you have a replication, you have a local database and a remote database. So the servers are there's two of them, but you could only have one. It's called Syn Gateway. And in addition to having a local and a remote, you specify a source and a target. So if you say that the source is Couchbase Lite and the target is Syn Gateway, you're pushing the data. If you say that the source is Syn Gateway and the target is Couchbase Lite, you're pulling. So that works well when you have a client and a server. Just maybe you're doing one directional replication, but if you start having bidirectional replications and other clients reading as well and writing, you start thinking about how would you manage all those reads and writes, and you obviously can't. So on the server, there are master-slave replications where essentially you will write to a database, then there's an update process in the cluster, and then all the reads can be done through other nodes, but all the writes have to be done through one node. This is really just specific to server, and you're not interested in that, but I thought I'd just share it, because then what happens when you have a multi-master replication is that every node has the same weight, and you can do a read as well as a write from every node, which means that there's an increased traffic between the nodes to make sure it synchronizes everything. But obviously, we can't wait for every node to be synchronized in order to accept a write or to get a read back from the system. So the way it works is that for reads, if you have a non-blocking, so if you have a user 1 and user 2, and this purple line here is just like a timeline. So that's a timeline, and that's the time frame for which the user is interacting with the system. If he reads a value and then writes the v1, but as long as user 2 is only just reading, there's no worry. vCurrent1 is updated. Then at some point, user 2 wants to write. So actually he reads first and then he writes, but he's reading v1 because they basically didn't write in the same time frame. So that's fine. And it just transitioned from v1 to v2 to, well, v2, v1, v0. But for reads, it's a bit more tricky. So, sorry for writes. That's the same one here. And imagine that now the second user is performing the same operation in this, there's an overlap in the time frames. What would happen is they're both doing reads. Maybe user 1 decides to do an update to v0, and we'd call it v11. And then the same user, before that write transactions has completed, decides to do an update as well, which will incur in conflict because they're both trying to update the same revision. And finally, I won't go into detail, I'll come back about the server at the back here, but what I'm going to talk about today applies whether you're using sort of a replicator interface like Couchbase Lite, or if you've built your own. All the stuff about conflict resolution, that applies as well. But there are a few things that are very different in the sense that, for example, here, you have the peers at the edge of the network, and you remember like the triangle of the three master nodes? Well, you could imagine that this phone and that one up there, which is basically the server, they're each having the same weight. So effectively, you can replicate the data down. Your server goes, like burns into fire for some reason, and you're able to push back. So it's almost like a data center recovery, failover. And we thought, okay, we've done the mobile to server and server to mobile replication, but if we could embed a web server into the Couchbase Lite framework, which would be optional, maybe we could also do peer-to-peer replication. And so I have a simple app that I'll demo right now so that you have an idea of like what we're doing. And I want you to all take out your phones. What do you think it might be? Guess where? Okay, so you could head to labs.couchbase.com/minihacks. Don't worry about the Android for now. And I'll do the same here. So please, I'll recommend to use your Twitter handle here so that we can avoid conflicting answers and we can actually pick a winner. So I think the Twitter handle is the best way to do that, unless you can all kind of synchronize right now and each decide one of them to be unique. So let's pick the Twitter stuff. And then when you click save, you get on that first picture. And what's basically, this is PouchDB running in the browser. It's a JavaScript implementation of the replication that is also implemented on Android. And just for the purpose of the demo, it's simpler to use a web app here. So here I'm deleting all of the images, and I'll start adding right, so it takes you to question 2. Who is that question 2? Oh, we need more. Way more. What was the matter? Did it not work properly? Try it again. Head over to, oh, did I hide the URL? That's not very good, is it? This one here. All right, show of hands, who's on question 2 now? Oh, wow, amazing, great. All right, so you can answer that, and then you'll have a little message for 2 seconds, and it will disappear, and then you can wait. I'll give you 10 seconds. And what's happening now is if I run a node seed.js3, I'm pushing another document which has a picture URL and some other information. And then that replicates back down to the browser, and there's an event listener in JavaScript, and then it reloads the web page on the next question. So what's that one? Yeah. Cool. That's getting harder, right? So I'm actually collecting all of your answers, and I'll aggregate them by question, and I also know who's the fastest at answering it. So we'll pick the winner at some point, a few winners maybe, and then you'll get some vouchers, Amazon vouchers, and stuff. Yeah. Whatever you like. It's open bar. So which one was that? Yeah. You're really good, actually. I had no clue. That one is hard. I hope you've got your Twitter handle in there, because that's how we're going to let you know that you won. Told you. Okay, let's do a few more, and then we'll maybe do a few more at the end, you know. So which one was that? Yeah. I don't even remember. I actually wrote that. Anyone know? Yeah. Who said Dubrovnik? Cool. Oh, one at the back too, okay. All right, so we've got about 18 of those, so we can carry on a bit later if you want. But I'll explain roughly how it's all laid out. So the Sync gateway here in the middle is running on DigitalOcean with a Couchbase server behind. But we're interested in the mobile stuff. So here we have, like, for example, a tablet and a phone, and it's in the browser. There is, so up there in orange it says Web PouchDB. And I was kind of, my laptop would be kind of on the side here, poking Sync gateway, adding documents and having them replicated to you. But the demo doesn't stop here. So this peer-to-peer replication is quite interesting, because you could also have here in purple an iPad, because I only have one Android phone, so I couldn't sort of do peer-to-peer between Android. So I had to use the iPad. And that would be kind of a master node, if you will, where all the Android phones would browse for that particular node on the network, find the IP address, and then sync those documents. So I can show you, basically it's also on Google Play. The reason you can't, the link was up there, the reason you can't use it is because the Wi-Fi of the cinema doesn't allow the multicast DNS to resolve the host name. So yesterday night I was in the hotel, it was working fine. I was like, yes. And like all day today I was trying to figure it out, but I couldn't. But basically, same thing, you enter your username and sorry? What, to work around the issue? Yeah, I could have done that, yeah. Come and speak to me afterwards, we'll get it sorted, because like, this is one of the things that kind of frustrates me a bit about peer-to-peer. It doesn't always work. And Apple has some framework called multi-peer connectivity to have the resolution work over Bluetooth as well as Wi-Fi. And just recently, actually not so recently, but since Android 4.0, Bonjour also works on Android and is compatible with iOS. So you can discover the host names between the two, but as I say, it doesn't always work. So here, I have the Android as a hotspot, and the iPad is connected to the Android phone, and I see that I've picked up a service, a Bonjour service, and I can connect to it. I can submit an answer, and as this diagram shows here, it will just save a document to the database and then push it to the iPad. But because the phone is not connected to the internet, and the iPad either, they're kind of in their own Wi-Fi, it will never get pushed back to the server. So that's where the demo isn't quite complete. So let's take those in different steps and see how it all fits together. So there's a bit of Swift code just because, yeah, as I say, I couldn't use two Android devices. But basically here what we're doing is a replication with Sync Gateway. The IP up there is the IP that's in the of the DigitalOcean instance. And with the manager and the database, we create a pull and a push, and we use continuous enabled. That means that it will actively monitor the database for new documents to push, and actively monitor the remote database, sync gateway, for new documents that were synced to that thing, and then pull them. So that would be using WebSockets or long polling. So that, like, those lines of code are the very classic mobile server architecture. Once you then include the Couchbase Lite Listener Gradle plugin in your project, you have access to a listener class there, and you instantiate it with the manager, passing in a port number, and then you call start. And this exposes the same REST API as Sync Gateway has to act as a remote database. So by doing so, another device can also act as a remote database. And the code here, for example, to do a push replication is very similar to the one I had just before. It's using the class method, creating the push replication, passing in the URL and calling start. And another line on the iPad, just below the instantiation of the listener, is to set a bonjour service name and type. So what this does, the service type is a way to, for example, all devices on the network, if they broadcast a service, they have to be part of a sort of class, a type. So printers will have a certain string, like depending on the brand as well. So it could be Canon or Epson or things like that. And so we use this service type hard-coded in the app on the iPad and on the Android phone, so that we can only listen for the stuff we want and kind of filter out all the other peers that are broadcasting some bonjour signals. The service name is a bit like a nickname. It's the stuff you put in the text box on the first time you launch the app in the browser or in the Android app as well. And then you just call start. Now on the Android side, it's discovering peers. So the process is a bit different. If device A here is the iPad, it's registered a service, it's broadcasting that service, and device B is the Android phone, and it's listening, and it's discovering services. The CBL listener port, for example, is 55,000. Service name is the Twitter handle. Service type is peersync._TCP. The first thing that happens is there's a message being sent to everyone on the network. And then device B decides that he wants to connect to device A. So it sends a request to say, I want to resolve the host name. And the host name isn't resolved as, it's not resolved until device B explicitly wants to connect to device A. And the reason for that is that the hostname resolution over multicast DNS is can take a while, up to 2 seconds. So if it had to resolve the hostname for all the peers, regardless of whether you wanted to connect to them, it would be pretty bad for performance. And then it returns the IP address, and then with that you can do a push or a pull replication. So on the Android side, the first thing you do is you instantiate the NSD manager, and then you use the instance method discover services, passing in the same peersync.tcp. This protocol DNSSD is nothing special, and the discovery listener, because it's asynchronous, will get called when new peers come online and when some of them go offline. So the interesting overrides here are the bottom ones, on service found, where we can filter out for all services that are not the ones that we've got. And if we do have one, then we can instantiate a new pair. The service name here is the nickname, and we send that to the quiz discovery listener, which then displays it in the recycler view. And the same for on service lost. When I click on connect on the Android app, it then uses the same instance manager and calls resolve service, passing in the one I want to resolve, and again a resolve listener because that action is asynchronous. And then in the listeners on service resolved, I get a service info which has the host and the port. The port will be the same as the one you were broadcasting on, so you already had that, but the host will definitely help to identify the pair. And then that code is very similar to the one I showed in Swift to push to the syn gateway. The implementation for PouchDB is, as I say, in JavaScript. I won't go into detail because it's very similar to the API names are the same pretty much, so I'll go over that. But I'll explain how the replication works because I think it's quite important to understand what's happening under the hood if you get to use such frameworks. Documents are JSON properties, hash maps, and any property that is prepended with an underscore character means it's reserved for Couchbase Lite. So the two properties you have to keep in mind is our underscore ID, which has to be unique, otherwise it may create a conflict, and underscore revision, which represents a state of your document. So every time you do an update, that rev increases, this first number here increases, so it's a bit like a Git repository, you have commits. And that way you can have a history of the commits and you know exactly when the conflict happened and you know how to resolve it. But essentially what happens is if Couchbase Lite wants to push to Syn Gateway, then Syn Gateway will say, what's new since we last spoke? And Couchbase Lite will say, I've got a new revision for that document. And Syn Gateway will say, oh, that's new to me. And Couchbase Lite will say, I'll send it over. And you may think that's a bit verbose because in the second one, if Couchbase Lite is saying, I've added 3, why does Syn Gateway need to know it's new for me? Why couldn't just Couchbase Lite send it? You know, if it knows it's new and the other one doesn't have it. The reason is because it's like a distributed system. You could have another pair that's pushed that revision, and because those wouldn't have connected since a long time, it's doing the redundancy work to make sure you don't push this stuff twice. The 2 documents for this demo were like pretty simple. So the ID here, in this one, it's an ID we chose. So every question has a question and then an integer. A type is a way to have collections of documents, a bit like tables in SQLite. And then some other fields. On the answer, as well, we have the nickname and the user answer and the time. When I post or put that to the database replies with the same hash map plus a rev property, and that's to tell me it's created a new document. That's the rev, that's the first commit. Say that maybe I want to update the question and I want to change the link to the picture. I will then put those properties again with the updated link and provide the first revision I got back, so 1 dash something, and then the database will give me back 2 dash something else. And it goes up like that. Also, we have a relationship here between the answer and the question. And so that's how we can determine, we can do a query to have all the answers for a particular question. And then we can do a sort on the time, and that way we know who's answered the question the quickest. Relationships in SQLite are really well documented, I would say, and it's pretty rigid, so you have less chances of messing up. But with NoSQL, it's pretty much like that. If you don't be careful, if you're not careful, you will think you're in control, but you're not at all. And so the one advice I have for you if you're going into NoSQL is to validate everything everywhere. So if you're on the mobile client and you're putting stuff in the database, validate every single property. Same on the server side. It seems obvious, but because it's optional, people tend to not do it, and then it creates a lot of problems, and it's hard to know where it came from, and even worse if it's in kind of the App Store or the Play Store. So to wrap up the demo, really what I wanted to show here was that the SYN-Gateway node is just a well-connected peer. And if you had, again, clients connected to a master client and then that connecting to SYN-Gateway, that could work. In terms of SDKs, obviously we have Android, but it's split into pure Java and then Android. So you can actually use it to, I don't know, if you want to build anything that runs on the JVM really can use Couchbase Lite. So actually the Raspberry Pi as well, if you want to do embedded hardware and things like that. And it's pretty neat because it will pick up from the sensors all the data as it's happening, and then at some point if you want to replicate, you can, but it's never going to go away until you want it to basically get deleted. All right, maybe it's a bit short here. I was hoping on the Android stuff to work so that you could download it as well and we could combine Android and web. But basically, the source code for this and other tutorials are on GitHub. And feel free to ping me on Twitter if you have any question about Couchbase Mobile, SYN-Gateway, and offline sync in general. I think we could come back to the quiz for a few rounds if you want. Or maybe I'll happily take questions if you want to discuss more about the general aspects of offline. Any questions? Any concerns you have about? Yeah.
Okay, we have a book for the best question.
Because you're sending JSON over the network, I'm curious about the security and the encryption of the data, and also compression. So if we're talking about phones and bandwidth limited and all of the syncing happening all the time, I wanted to know if you have some sort of a benchmark, like how much data would be used? Or
Yes. So you would use way less data than if you were using something like a content provider and some custom logic to be able to determine when to fetch and when not to fetch, because nothing will get fetched again unless you want it to, unless you change the business rules and actually add some data. In terms of compression, so SYN-Gateway is using gzip, it's sending everything through compressed. In terms of security, so it's important to know how Couchbase Lite is built. Basically, it's built on top of SQLite. And the main reason for that was that in order to ship a version that would be usable without waiting for 10 years to build the storage layer as well as the replicator layer, we decided to go for the replicator layer using SQLite. And now we're implementing ForestDB, which is a blob storage engine, which is way more suited for JSON, and will have drastically better performance. It's already available on iOS, and it's coming to Android in about a month when the 1.2 version comes out. For encryption itself, yes, so because we're using SQLite, we're using SQL Cipher, and you have the choice to use that to encrypt your SQLite database. And then for ForestDB, that's already built in. So it's there are two different options depending on the storage layer you use.
And last one. What about the revisions? So is it possible when you query the database to go back in time like you do like with GitHub? That you can, oh, I made a mistake here. Can I revert this change? Is that built in or?
So it's a lot like a GitHub repository where every person contributing to the repository has a master repository, if you will, and then they can do whatever they like, and then it can create conflicts or not, and they get resolved. The only difference is that the history in Couchbase Lite is only made of the revision and the ID. We don't keep the user properties. So we call the user properties any property that doesn't start with an underscore. So any stuff in your apps that you store, we're not going to keep that once you update the document. It'll be carried over, and the stuff that you removed from your hash map when you save it will get removed. We also, I didn't mention, but you can use attachments as well. And attachments are basically stored on the disk. It could be any storage, any content type such as music, video, or pictures. And they get referenced in the document. And the property for that is called underscore attachments. And then that's an array, and it has a lot of metadata on your attachment, where it's located on disk. And also it has the attachment name is the hash of the attachment. So if across documents you're using the same attachment, it's actually only stored once on disk. So it's deduplicating as well. And those will get removed when you delete revisions. So you know you can't kind of come back on the history and have like an undo button. Yeah.
How do you manage and resolve conflicts?
Really good question. I think the only little drawing I have to explain this is oh, I hate animations actually. Yeah. On that one here, remember I said that the first number was sort of the generation number. The revision IDs would look like this: 1 dash a hash and 1 dash a hash. They would both be created on two different offline devices, because Couchbase Lite won't let you create a revision unless you provide it the revision number of the previous revision, right? It won't let you sort of do conflicts, which is good. But if two nodes are offline, they can do that because they don't know about each other. And so when they come back online, there's a method on the document called getConflictingRevisions. So you can have a database listener that also listens for conflicts, and then you can have some code to iterate. So it's an enumerator of revisions you get back. You have the content of all of those because they're sort of on the tree. They're kind of the leaf nodes. So we're keeping those around. We're keeping the content of each one. And then you decide if you want to do a merge, if you want to pick one over the other, if you want to display it to the user. And the way you resolve it is simply by deleting everything and making sure there's only one branch left. Yeah.
You said that we can set a P2P connection via some Wi-Fi, Bluetooth, or network. I have an Android-specific question. How do you handle what channel we should use? Network, because network can be slow. It's a local network. Is it connected to internet, or we can use Bluetooth? What is faster? So, and some can use Bluetooth 3.0, 3.0 that is more power, use more power, and 4.0 is less power. So, how to handle it?
So for example, over Wi-Fi, I would say like it's way faster than if you had to replicate through Syn Gateway. So sometimes I don't have it there, obviously, but if you had like loads of attachments and you did that peer-to-peer, it would be quite seamless. I probably think Bluetooth would be slower than Wi-Fi, but I feel like users are more inclined to be pairing over Wi-Fi than over Bluetooth. I mean, usually people pair over Bluetooth because they intend to pair, whereas over Wi-Fi, maybe they're sort of in the region. For example, the Pocket Cast app, they now have a nearby feature where you can see other clients, and then you can see what podcasts they're subscribed to, and then you can subscribe to those without even having to intentionally try to connect with that person. So it's kind of broadcasting everything that it's searching for everything around. I would love to know of a way of having Bluetooth and Wi-Fi sort of peer discovery because I haven't managed to do it over Bluetooth yet, only Wi-Fi. And then there's the Nearby API as well that's new on Android. And that's interesting. It's actually using the peer-to-peer components to do the discovery, which is a combination of Bluetooth and Wi-Fi, so there must be a way of doing it. But then the messaging is happening through the cloud. So similarly here, you could do something where you would only use peer-to-peer to discover and then Syn Gateway to replicate. But I feel like this is a bit of an overhead. If you've already discovered the host name, why not just push to that user? I don't know if that answered the question specifically, but yeah.
Someone else? Okay, so which question was the best for you?
I'll take the first one. Actually, I don't remember. You had two questions. Yeah. But if I had to choose then I'll choose the conflict resolution because it's something that's quite tough to do, and sometimes some frameworks have an opinionated way of resolving conflict, and sometimes it's easier to do it that way. But we kind of leave it to the developer to choose the way they want to resolve the conflicts. Sorry? Yeah, I know. I said if I had to choose somebody else. But maybe you've won a quiz, and actually we can carry on doing some quiz, and you'll get a prize as well. So which one is this one? Easy. I knew that. And I'm rubbish. Yeah, Budapest. That is really hard. No? Yes. Who said San Sebastian? You get a prize as well. Any French person in the room? Yes. Well done. I know some people know, but they don't want to say. It's Prague. Any Portuguese in the room? Yeah. Yeah. I don't even remember the name of that one. That one looks amazing, though. I really want to go there, so I'm actually going to have a look. Where did I put it? It's actually on Malta, but the name is unpronounceable. I think it's that one. So that's question 12. Yeah. Marsakslok. Yes. What? Oh yeah, oops. And then after that? Oh my god, that's it. It's the end. That's amazing. Like, that's really pretty. What was it? I think it's Italy, somewhere in Italy. Yes. You're very good. Yeah. You know, all right. Not in Europe. It's San what? Yeah, actually, let me check. I'm not sure. Wait, I mustn't go too far. Yes, Sao Paulo. And I think there's one left. No. But yes. Who, what did you say? Yes. Who said that? Wow. How did you... oh, maybe... Did you notice the answer was in the document? So maybe if you're sniffing the HTTP traffic, you get the answers. How did you get that? Oh. Yes. It's... All right, cool. I'll do some crunching on the first ones we filled in, and then I'll tweet out to let you know. All right, cool. Well done, everyone.